Now, when we solve log equations, you're going to have two situations. One is you're going to have log equal number, and we've already been solving those. With the log equal number type of equations, we just rearranged it to the exponential. When you have log equal log equations, those are even easier because then you can just reverse logging both sides. Okay. All right, so we'll look at five examples, and then after this, we'll sure have some time. You guys can just get started on the homework. Now, all right, with this first one, we can just reverse this to the exponential. Same thing with the second one. The third and fourth one, we're going to have to do a little bit of work first. The third one is where we have eventually a log equal log equation. And then the last one, we have to do a little work first, and then it'll be log equal number equation. Okay, so for this one, understood base is 10, the exponent is 2, the value is x plus 4. Then you just solve that. Right? All right, now the second one. Okay, it's the same problem. Now the base is explicitly written, so it's half. Our exponent's 3, and the value is 3x minus 3. Did I copy that right? 3x minus 2. All right, so then 1/2 to the third power equals 3x minus 2, and then you just finish it from there. Okay, and then the third one rather. Okay, so 2 log base 5 of x equals 3 log base 5 of x. Okay, so now we apply the power property first. The 2 is going to become the exponent of x, and over here the 3 is going to become the exponent of x. Did I copy that right? Oh, this is 4. Stupid me. I'm sorry, y'all. Okay, so that should have been a 4. So the 3 is going to become the exponent to the 4. Now, since we have a log equals log and the bases are both the same, that means we can reverse logging both sides. Or you might say drop the logs and then solve this problem. Now, in general, when you solve square root problems, which is the next step, you want to put plus or minus. So plus or minus the square root of 64. However, in the original problem, we can't have a negative for the variable here because the log of a negative value is undefined. So in this particular case, since the original problem is undefined for negative numbers, we're going to reject the negative solution. Okay, and again, that's the thing when you're dealing with functions that have undefined values. You may get a solution because the end resulting equation doesn't remember where it came from. This equation doesn't remember it came from a log equation. So it'll solve it, but since it came from a log equation, we have to exclude a negative number. All right. Let me pause for a couple seconds. I'm hoping this is really a review of things that we've already been doing or that you already understood, but we'll see. Okay, so the last two. Okay, so we have, log base 2 of the x plus 1 plus log base 2 of the x plus 7 equals 2. Okay, so we're going to use the property, the product property. And so the x plus 1 times the x plus 7. And now we can switch it to the exponential. So our base is 2. Our exponent is also going to be 2. And that's going to equal this product of binomials. Okay? And then you just solve that, you're going to get 2 solutions. But then you got to go back. If you add 1 to this x and it becomes a negative number, you have to exclude that solution. All right, same thing here. If you add 7 to this x and you get a negative number, we're going to have to exclude that. So that might happen when you get down to the end. You might wind up with one of the solutions, or maybe both, not being possible. Again, that's because the end resulting equation doesn't remember where it came from. So you have to check and might have to exclude some solutions for that reasons. Okay, and then the last one using the ln. Okay, so now we'll first do the quotient property. So the x plus 1 divided by the x. And that's going to equal 2. Okay, now we can switch to the exponential. So the base is e, the exponent's 2, and that's going to equal the x plus 1 over x. Okay, now there's a couple ways you could go about this. You could cross multiply, all right? But let me show you a little trick. Since we got a single denominator, we can actually divide this a little bit. So that's what I would do. So x over x is 1, and then plus 1 over x. Okay, so now we can subtract 1. Okay, and now we want to solve for x, so let's reciprocal both sides. Right? That's helpful. Now, if you didn't do that, if you went ahead and cross multiplied, okay, well, then you're going to have to get the x's on the same side. So then the next step would be to subtract x. And then you factor out the x. And then notice when you divide, you get the same thing.